Hello, morning.
Hello, morning. Well, hey David, I got your email. Yeah, it's been a long time since I looked at that section of the spec. The way that I read that is the common clock is just the clock on the link side of the LPI is what I'm really gathering from that. Does that make sense? So there's like a
No,
you know
but
there
the common crop, right? Then because normally on the receive side you are actually extracting the crop from the crop plus and crop minus, right?
uh-huh.
Yeah, and then what is the relationship between this common crop to this? Because normally from what I read from the spec, right? So basically, I mean if it is a single slice is okay, but let's say you have multiple fragment, right? Then you will have four crop coming in, and then if the spec say a common crop, what is the relationship and the requirement for this common crop compared to the rest?
What is the relationship between the incoming clocks and the common clock?
No, no,
Um,
the common crop versus the receive slice crop.
I
Uh,
don't know.
because, yeah,
It
yeah,
says,
because
I
it
mean,
says if you
it
refer to the table, right? So basically, figure 44 show that okay, the first column is the TX slice crop, the receive slice crop, and then there's a system crop. Okay, that one I'm fine with that. And then there's a RX common crop, and we in the spec it does not describe what is the RX common crop relationship and requirement compared to the RX slice crop.
hold on one second. I thought I read that it was supposed to be, let's see, all the slices are either synchronous or
Because the table the table say crop relationship, but then it's not very clear after reading it through it. Yeah, so that's why I asked you the question.
yeah. I mean, everything is being synchronized to the common clock. But I mean, they talk about how the other clocks are mesosynchronous. I kind of infer that the common clock is supposed to be mesosynchronous to or synchronous either way to the slice
Mm.
clocks. But I don't know if it explicitly says that. We can ask, wait here, it says all, let's just slice per fragment if it was determined deserialization. In this case, the slice clocks are mesosynchronous with respect to each other. Um, and if all the slice clocks are mesosynchronous, then that would imply that the common clock is also derived from a similar clock, right? So that the whole point of the common clock is it's post skew correction, right? So all the slices, all the lanes are all one single clock. That's why it's called the common clock. Whether I mean, they don't really do anything with the common clock because then I think you have to bridge to the system clock. So that might be implementation defined, but we can ask the other David, the one that wrote this
Okay,
chapter, what he's
okay,
he's
okay.
he's thinking.
Yeah, yeah, yeah. So I think it will be useful, right? Because I was reading through it, and then yeah, I was thinking, what is this relationship? Because I was
Yeah,
checking through the document, there's a lot of common crop, common crop, common crop. But then, if you refer to the picture in the, there's no indication where is this common crop is. And if you refer back to the five spec, right? The five spec diagram show that the received crop is coming from the crop plus crop minus, right? And then
yep,
it will generate the RXP crop. and the RXP clock will go to the RX link layer, and then the clock there's a clock which is the system clock where you do the synchronization, right? Between the protocol as well as the transaction layer. But
Yeah,
then there's no relationship between the link spec versus the file spec regards to the common crawl.
yeah. And my guess is that it's supposed to be implementation defined because it's not seen externally to the layer. It's just a common clock that you're descaling to, right? But
Um,
again, we can ask David if he has
yeah.
if there's any other.
Yeah, correct. Because normally, if I read the link spec, anything that is how to say implementation specific, they will write some note there, right? Say this is implementation specific, but I can't
Yeah,
find this in the common crawl.
yeah, okay, yeah. We'll get that clarified.
Okay, thanks a lot. Thanks for your help.
Hey, everybody. Uh, David emailed me a question about the relationship between the RX block and the comments block, and so we'll get some clarification on. Um, so yeah, so I guess for agendas for today, I don't have a lot. Unfortunately, I'm traveling again, so but I and so sharing is a little bit of an issue, but I don't have anything necessarily to share. I'd like to talk a little bit here about. We can continue our conversation on Chad C2C and the like. So, Jeff, I see you're on. Well, I got your text. Just been a little busy. I did take a look at the sheet again,
Uh-huh.
by the way, and honestly, everything just seems fine.
Okay.
So, I think we just need to, next step would be just finish out the granule counts and stuff like that. Um, but I mean, the bits are what they are. And your comment last time about keeping field orders
Hmm.
to what the spec is makes total sense too. I mean, again, no skin off anybody's back. You might as well be as compatible as possible in case like you said last time. Again, you're using a post serialized controller interface or something like that. Um, So yeah, so I think we can, you know, again, if you're proposing a next step there, then I think that's where you take that, right? Just use what you have and add the padding in charts, right?
Yeah,
Or in tables.
I've started to kind of pull this together. I can go ahead and share what I've got so far. It's not there completely, but might be helpful. So yeah, in the introduction here, I just kind of am tying it to the C2C spec and provide a link to get there. I think this link will work for that. This is issue A released in February.
Mhm.
Because that'll be specific, right? And then I've just got here something on message class about um, that C2C seems to be the packetization is similar to what we're doing,
Mhm.
and that we're just going to go leverage these message structures, I think is what they refer to it in the C2C spec. The one area that's kind of interesting is this message type is I think it's synonymous with our TLP type, but it looks like they use it for selecting the message format, whether if it's short or long, where what David had specified in the V1 profile, which has variants in it as well,
Yeah.
is that the format is selected by the opcode, the transaction opcode.
Yeah. I was gonna say, yeah, well, you know that before you get there. Mm,
Yeah,
Okay.
so I think what this means is that, we have to pay attention to this message type that's coming in as input, but then it could pass through to the TLP type. Um, but we don't have specific values that we care about for the TLP type. They just have to be unique, right?
Well,
But
I
this,
mean, it depends on. I mean, yeah, absolutely. I think, so like we were saying, like, visible interfaces to the controller, right? Because I think we usually treat, because most of our TLP types are different buses in many cases. And so you're actually coming, and most TLP types are coming in on different physical wires
Well, the TLP
here,
type, there's
depending on how the integration works.
yeah, we're getting about every fifth word, I think.
Oh, sorry.
That's it.
One second.
No problem.
All right. Sorry. Does that help at all?
I don't know. Just talk and we'll see how it plays.
Okay. Anyway, all I'm saying is that normally the TLP types are different wires coming in. And so I think this would be a change for most controllers, but it's not the end of the world.
Yeah, I think it just has to be that, well, we'll have a different way. Like with C2C, we'll be looking at message type that's coming in as input, right? Versus, some opcode encoding. But I think we just have to pass those message types through so that we recover them on the other side.
Yes.
Yeah. And then I'm not sure about all the crediting mechanisms because they have something in C2C. I don't know how closely it aligns to what we're doing and whether we kind of have to signal between the two or if we can just write on our credit mechanism. I have a sense that they define C2C after looking at, the specifications we had. Is the sense that we have at Ventana because it looks fairly similar in many ways.
Okay.
But
That's
I
good.
yeah, I put this note here that I've got to go look at the crediting and all that. And I've been trying to get input from David. He just got back from vacation, so and he's super busy. Hopefully I can get his attention and sort that out. And then, for the different message types, we have these sections. I'm choosing to put the long and short format in the same table. I don't think we've done that before. Usually they're like different sections, but I think it might be helpful to have them in the same section so you can kind of see how the two messages align.
Yeah. So we put them, at least, well, I don't remember all the specs, but like for AXI, we put them in the same section, but they're separate tables.
Right.
Yeah, I I'm ambivalent. I don't know. Either way is fine, whether it's another table or if it's another, um, it's just another column. That's fine.
Yeah, so I don't know. We can take a look at what I've pulled together here and see if this is maybe we want to change the formats of the event or something like this or not. But I thought I'd just go ahead and take the plunge and document it this way and we can discuss it. I think in our tables, what we typically do is the first transmitted signals or fields, they're at the bottom of the table as you go up. And here I'm doing it in the same order that C2C is doing it in transmit order. And I think it's from the low order bits to the high order bits. And only including the widths, the bit widths, rather than the overall packet bit position.
Wait, sorry. So this is not the field position. This is just the widths. Is that what you're saying?
Yeah, these are all the fields as they go out in transmitted order from the lowest bit LSB to MSB.
Oh, okay. All right. I misunderstood you. Okay.
And then these are just the widths of each. So you don't really get to see the indices, but you get to see how much the width is of each of the fields.
That's fine. That's with everything. Everything else we did the same thing.
Yeah, and then to your point, how it's packed into granules, I don't know if we have to look at that or is there a way we can kind of document it on the table here where the breakpoints are, or should we? Do you think is helpful or?
Um, I need to go back and look at the other specs. For our other discussions, we did calculate the granule
Yeah.
count. but I don't remember if we put in a spec or not. I'll need to go back and look at that.
Yeah, I remember you had a spreadsheet, a detailed spreadsheet that, calculated all this, or you.
Yeah. David gave me he had pre-done some formulas for it.
Yeah.
And so I kind of baked those into all of the AMBA buses and show what the granule count is because we were playing with field widths and stuff like that and wanted immediate feedback.
Yeah, I think it's super helpful, right? Because then it says if you want to take a subset of these signals, do you want to organize those at the first transmitted? In this case, we want to follow the transmit order, but in other variants, maybe we want to tune those so that we can minimize the number of granules that have to be.
Yeah. I'll as I get time, I'll
Yeah.
take what you have and spin up another sheet of that and
Okay.
show it.
Okay. And these are essentially just a re-representation of the tables in the C2C spec. I think it's important to put them in here, and I just did reference to the section so people could index to that. To your point, the reserved 0, I don't think we need to transmit these because if we own both sides of the link, then this is just data that we don't need to transmit. It just has to be, I guess, recreated on the other side, these fields.
Right. Yeah. I mean, we can trim it to a granule barrier, or we can just remove it, I think. Because it's kind of implicitly zeros anyway, I think, in the spec, if I remember right. So it's yeah, either way.
Okay. Okay, so yeah, I've got to finish out these tables. I noticed that there was like messages in the C2C spec as well, like we have. So at some point, I guess I'd like to discuss, should these messages be part of the TLL or should they be a variant, let's say a general variant that all of the profiles carry? So
I mean, I'm not clear. You mean, are you asking whether we should treat this as a normal variant or we should treat this as something special?
I don't know. I kind of feel like I get why we put it in the TLL, these message formats like the credit TLP, because
Oh,
it's kind of implied in all of the variants that it'll be supported. But I'm just wondering if we should break that out as a separate variant, as a general variant, and then people can refer to that in the profile. And not all of them, like for example, the idle TLP, I don't think it's not required for C2C, right? It is, I think it's a BOW specific thing to keep the phi signaling and aligned.
right. But that's in the idle TLP, I think, is in the main spec. I don't think you have to put it in the variant.
No, but that's what I'm saying is maybe we should pull it out of there, any kind of TLP formats and keep those as variants, right? And then you have the flexibility of whether you use them or not.
Well, okay.
Idle's a special case, right? Because I think that is more of a phi specific, BOW's phi specific item.
Yeah, but it's also not required to be used.
Hmm.
So if you're using UCIe, they just simply don't use that TLP. But I mean, I guess we can have more conversation on that.
Sure.
Um, are you sorry? What was the comment about the credits though? Are you saying um,
Well, we signal credits in the aux field, I think, as well as we have a credit TLP.
right?
And I think C2C always has a credit TLP, well, a message format.
But we're encapsulating C2C, right? So that credit doesn't necessarily apply to us, right?
Well, we do have a TLP for credit. It's just that you don't necessarily have to use it because I think the credits are communicated in the
they're optionally communicated in the ops field. Yeah. I
Actually,
guess my
no,
point
actually,
is that I don't think we should require a transaction layer to open up the the protocol packet, to find out if there's a credit there, right? So we shouldn't be using the credits whatever credits that are communicated within the C2C packet. We don't know anything about, I guess. Normally.
Yeah, I guess that's something I need to sort out on the C2C, how the credits are handled. Maybe,
Yeah.
I'm not sure.
Yeah.
And actually, I think I need to correct my statement. I think we always use a credit TLP, but we also leverage the aux field to extend those. That
Well, the
message.
current TLP is just like a catch-up mechanic, or a start, right? So if you have a lot more than can be communicated in the ops field, then you send the current TLP to start the engine. So, but either way, yeah. Again, I those credits that are communicated in either of those positions pertain to the link, and it's effectively the FIFO size and a link controller, but I think the Chai C2C credits would be whatever FIFO size you have in the Chai C2C itself, right? Otherwise, I think we're talking, I think, about two different FIFOs and two different layers that would need to, they're counting FIFOs differently. I mean, if they were all one controller, you could merge them, but I don't think you can make that assumption.
Let me share something else here. So can you see that?
Yes.
Yeah, so I kind of looked at the miscellaneous packets as something I was working on last week. So, we have messages that are always 26 bits flit or whatever, or message. And we have 14 bits of payload. In the case of like when we're doing the credit, the CRD, TLP, I think that aux field, 5 bits adds so that you have a 19-bit field payload for the credit grant. Where when you kind of look over at C2C, they've got an 80-bit packet or message format.
Okay.
So I started to kind of track all these different messages that they have on C2C and how it correlates to what we've got defined.
Yeah, I need to go look at the C2C specs some more.
Yeah.
Not sure what those packets do.
Yeah. And then I'd also try to kind of correlate between the different other messages to what we had. So the one thing we have missing is a write request data. And maybe we need to kind of look at, is there any value to that?
What does that do?
I think it's a write request, but it's delivering data all in the same request or message, where I don't know if we have to do a write request and then follow that with a data transaction or message.
Okay.
So maybe it saves some overhead. I don't know. I have to go evaluate that.
I'm trying to remember Chai now. It's been too long.
Yeah.
Okay. All right. Yeah, I'll take a look at that too.
Okay. So anyhow, that's where I'm at with doing the C2C mapping.
Okay. So do you feel like there's anything we need to be discussing on sorry. Do you think there's anything we need to be discussing on the UCIe binding that we've, that Ventana presented?
And I can go ahead. I know last week you wanted me to go over the contribution, and I can.
Yeah. I was hoping we could discuss it. I don't know if there's really anything. Please share, and then we'll talk
Yeah,
about whether there's anything to discuss.
should be sharing it right now.
Okay.
I can do a quick run through if you want me to, and
Sure.
okay. So aside from all the OCP stuff on the top, I'll start in chapter 3, the scope. I broke this into a base design and product layer specification. This is kind of an OCP format. It may not fit exactly the same, but I thought it was kind of an interesting overlay. Being at the base is, let's say, the TLL. The design would be, when you start defining the protocol mappings, and the product layer is kind of really a profile when you mix a bunch of those variants together and it specifies a chiplet link specification. So anyhow, that's how I broke up this document. I went ahead and put a link to our link layer wiki in this document. So when people pull up this contribution, they can go right there and see everything that we're working on. And then so I start out with the base specification here. This is really just talking about the TLL again. So we did a table, I did a table with David here of the different layerings and how it compared to UCIe. I think it's fairly accurate, so I wouldn't expect people have issues with it, but let me know if there's anything here that jumps out. But the system interface really is not addressed in UCIe other than PCIe and CXL flits that are defined in the spec. Everything else is out of scope. And so this kind of gives us an opportunity to do these profiles and variant mappings, to higher level protocols. ARM, the C2C protocol is essentially kind of a variant, and it's how it maps to the flits, the UCIe flits, FDI flits. The packetization layer here, we've got the transaction and upper link layer is what David was breaking. He broke it into upper link layer and lower link layer. In the TLL spec, I don't think they're clearly defined, so maybe that's something we work on over time, such that we have a more PHY agnostic document, for the link layer, the transaction link layer.
Yeah,
Um,
the original definition wasn't very clean because the assumption was it was all one piece of logic.
mhm,
Um,
mhm.
so yeah, I think then yeah, there's probably more work we could do there.
Okay. So just going on, this is just a rehash of the TLL and the packet formats here. So I think this kind of stands on its own a little bit and it refers to the other specifications. So that's why I think we probably don't need to update the TLL anytime soon. But the key thing was the LLP ordering, which, we defined here. I think it has to do, I guess, with, and David's the real expert here, but the number of n bytes on the interface, you just have to make sure you adhere to these orderings. And once you do that, then UCIe will ensure that the order comes out right on the receive side. But so we've got an 8-byte format, a 16-byte format, 32 and 64. Um, and then we talk a little bit about error correction here. We're using the raw format because we think it will always bypass the CRC retry mechanism. And so we rely on the forward error correction, the secded type encoding we have in the stream. But I guess if the UCIe adapter layer does enable the CRC retry, then all of the error correction would happen outside of our forward error correction. So we have an overhead in what we're communicating, but you know, the ability for it to recover from any kind of errors, it really relies then on the CRC retry mechanism. And then I'm pointing to the repositories that you set up, Brian. So I think these should point to those new repos.
So one note there on those CRC.
Okay.
It you know, if somebody has both mechanisms, it does make sense. And again, I'm not sure how they would do the CRC since there's not additional bits to transmit the CRC in the packet here. But if they did do that, then it makes sense to process the ECC before doing the CRC, which, you know, I mean, it gives you potentially more error resilience over
Yeah,
small bits.
I don't know how you can do that, right? Because once you go into the UCIe adaptation layer, it handles all this, right? So
Right. You'd have to have a custom controller that was focused on this.
yeah. I mean, it's something we could talk about over time as to how we change the order.
But
So
again, we don't, there's not extra bits here for transmitting the CRC, so I don't know how you would have CRC. If you're, this is the same problem I was running into with the FlitAware format, that 256 byte FlitAware format I was talking about. It had
yeah.
it has the CRC bits there, right? So you
Mhm.
have to do it. But again, the note there was if you had a controller that was doing one, then do ECC before CRC. But I don't think I don't think you can I don't think you can do that on this on a raw format because there's no bits.
Mhm.
Anyway, sorry, go on.
No, it's okay. And then I made reference to the, in this case, it was the contribution loader contribution, but in some cases, I'll reference the GitHub as long as it's in existence and stays there, the links will be live. I linked to the UCIe specification location website such that you can see all versions. I don't think anything that we've done here is sensitive to any particular version, so I would expect UCIe 3.0 to be applicable here. Then I go into the design specification and talk about variants, and there's the variant repository, links to you know, these prior contributions. And then you have the product specification, which is also very short here, points to the profile repository and the Veyron V1 interface profile that we'd done. And that's basically it. That's the whole contribution. I think you know, it covers everything in terms of the UCIe binding, and then also gives us hooks to point people to help work on these profiles and variants repositories over time. Any questions or? If not, I'll turn it back to you, Brian.
Oh, sorry, I was on mute.
Oh,
Sorry. Sorry, the primary importance of the granule ordering in that interface there is just making sure that the first granule that has the header in it is out first on a link, right?
yes. And I think if you have different interface widths on either side of the link, it preserves the order of those
Yeah.
granules. Yeah. So I think in BOW it assumed that the width was the same on both sides. And in this case, in UCIe, that's not a hard requirement.
makes sense. So we still need to, I guess, define how we're going to be integrating this into the specification too. Do you
Mhm.
have any particular opinion, Jeff, on this is an appendix or?
No, I think that was my comments about how do we make the TLL more phi agnostic. So I think I forwarded you a document, some initial thoughts. I guess I'm not ready to present that here, but
Yeah, you were actually talking about moving some things over to the BOW spec.
the BOW phi spec, yeah.
Yeah, yeah. So that might be something we need to have a larger conversation with a lot about what his feelings are on some of those things. I don't feel
And
like I have a stake in that race. I don't really care where it's at, but he might have a very strong opinion about it.
yeah. And if they don't want to take it on in the phi specification, does it make sense maybe to break it out into a appendix or something, or a separate document, which is some kind of interfacing adaption layer maybe between the BW phi and the link layer? I don't know.
I mean, I think we have a couple options. I mean, we can make it an appendix in the current document.
Mm-hmm.
We can restructure the current document and chapters to make them all a little more, to group the stuff that's BOW specific into one chapter and have a separate chapter for UCIe. Probably a non-trivial amount of work. Like thought about it too much what that would take, but it's definitely a lot of chapter headings changed, and some of the intros would have to be reworded at a minimum. Though there is some language kind of sprinkled throughout the rest of the layers referring to bow. So it would take, like I said, non-trivial amount of effort.
Yeah.
And then, like you said, the third option here is to make a separate document, and then what pieces we pull out in that separate document, I guess, are TBD. I mean, from a separate document point of view, what you've got already together kind of already handles that potential use case, right? So if people want to jump the gun on this and just do it, then your document kind of already covers that. I think the what we're missing is a more unified story. And again, whether we reword some things in the current spec and then add this as an appendix, or whether we completely restructure the document, I guess is the bigger conversation.
Yeah. Like I said, I don't really think it's time critical, because I think people can look at the contribution document and maybe, understand how all this would how it works with UCIe. But I don't know. I'm not opposed to working on the TLL if you want to restructure it.
Okay. Well, let's do this. Let's see if we can figure out a way to talk to a log. And then we might need to go to a BAL meeting and then talk about like which pieces they might want to take on,
Mm-hmm.
and see if that makes sense. I think, like I said, I think in the past they've kind of steered away from it because they didn't want to be, because people implement all sorts of things on top of BAL. I've seen implementations that are transmitting on, raw DAC signals and things like that. So, or sorry, ADC. But anyway, yeah, but it doesn't really keep them keeping it as an option in their spec. If it's really a question about whether they want to maintain it, I guess, because then it becomes their problem.
Yeah.
But we probably need to do some additional work if we do that. I think the goal here is to define a clear LPI from their perspective that looks a little more like, FDI, basically, right? So that
Yeah.
we can have a separate link layer IP block that is that is not tied to FIGS closely.
Yeah. Yeah, I
And
just,
I think,
I'd
and
like your eyes and
we talk about LPI and our link physical interface in the link layer document, right? But we don't really draw a hard line there. It's more concepts and what you have to do to go from one to the other one. It's not a hard perimeter in my mind.
yeah.
So that would need to be more clearly defined.
Yeah, I guess when you get a chance to look at maybe some of the suggestions I have, and give me feedback on that, then perhaps we can discuss that further. But I don't feel like I'm well equipped, given that we weren't involved for quite some time when we moved to UCIe. So I think you have a much better idea, and others as well, like Liam maybe has a better idea as to how the whole document's structured, the TLL document is structured, and how it, make more sense to kind of repartition it in different ways.
Okay. All right. I'll take a look at more of that. Again, maybe we need to set that meeting.
Okay. Okay. Yeah, for me, I wanted to focus much more on variants and profiles going forward up to the October conference. That's where I'd like to spend the time.
That makes sense. I think, again, with the most recent release, I think we have a letter then. I think that's where the gravity is in terms of fleshing out the standard.
Yeah.
Are there any other buses that we think that are missing here? I mean, we have variants for, I'll try to remember which ones we actually put up there. Obviously AXI, I think I put AXI Stream. We've done ones for both for ATB, but I'm not sure if I pushed that up there. And I can't remember if I did any other ones up there, but I mean, there's other AMBA standards. There's other buses. We've talked about other chiplet standards, and I'm trying to remember the names of them, but I'm blanking at the moment. Sorry. Something about like Bitstream or something like that. Somebody had suggested at one point, and then there was something else. Anyway, if other people have other buses that they that they think are important, and we need to
Yeah, I think this
I
is
just
what's
took a stream.
yeah.
Yeah, I guess I didn't put HTTP up there. Oh, and there it is. No, never mind. It's the first one.
Yeah.
Yeah. Okay. So yeah. So if I don't think other ones, I mean, some other common AMBA ones would be like APB and AHB. But I think the general assumption was that those are easy to convert over to AXI, right? So most fabrics have a trivial gasket they can put there. And AXI is more capable. But again, if we did something like APB, it would definitely be fewer bits.
Mhm.
I think you do have a problem with non-posted, consumption of a bus and stuff like that. So I think the original assumption was that if you were going to be doing something like that and you needed something like that, it would probably be more of a sideband operation anyway. But we don't, since we're not really doing bus mapping on sideband explicitly, then maybe it makes sense to do it. Now, you know what? I take all that back. I don't want to deal with that. If somebody wants to do an APB version, then they could do an APB version. I mean, there's just way too many other headaches we need with that bus for going over a chiplet.
I think what would be interesting is to go work on generic profiles and think about different use cases, let's say like a memory interface or an IO interface, the IO chiplet interface, and then look at how we can leverage these variants, and it might pop up other variants that we need to address.
Okay.
Just a thought.
Yeah, there's only a kind of a couple that are easy to point out, but maybe we can start a sheet for brainstorming profiles then.
Mm-hmm.
Okay.
I think you had some use cases too of like a split MMU across the interface.
Yeah, using AXI stream and the like.
Yeah.
I think the unfortunate part of that is that it does assume some stuff that it's above what we would normally consider the profile. But I had to go put some thought into it and try and resurrect my notes on that subject. Because well, again, this is very ARM architecture centric, which I guess is another point. But at least with ARM and split MMUs and stuff like that, you end up with the fetcher might be on the other side, on a different side. The walker might be on a different side than the translation of the buffer. So they use AXI stream. But having that as a bus and then just talking about, you can disaggregate a TDU I can't remember that block, the SMMU block
Yeah.
there. But anyway,
TCU,
yeah.
TPU,
Yeah, TCU. You might be able to disaggregate that across the system. So that, yeah, I could put some notes together on that. And at a minimum, even if we feel like it's separate from a profile, we could treat it as a white paper or something.
Mm-hmm.
The same kind of goes for trace bus, right? Like exactly how you deal with trace bus is a bit of an issue.
Mm-hmm.
There's some things also not covered here about how you synchronize timestamps, right? Because trace bus relies on common timestamps and stuff like that.
Yeah.
Whether we want to deal with that in the standard or whether we just say it's implementation specific is an option. But yeah, there's a handful of things we can probably put down that are useful information.
Yeah, I think if we can kind of demonstrate with variants and profiles that we could support very flexible system compositions, I think that might be helpful because I'm listening to the system group and they're defining, certain architectures, integration architectures. ARM has done the same with their chiplet system architecture,
Okay.
on types, right? And that is, I mean, it's an interesting effort. The question is, does it apply to everybody? And can we come up with flexible means to say, with these type of variants or protocol support, you can have a lot more flexibility in how you want to compose the system with chiplets, right? And so it's much more open and gives more freedom in how the integration's done.
Okay.
Yeah.
Sounds good. Yeah, let's start off with some brainstorming in that respect and then see what kind of papers we want to put together.
Okay.
All right. Anybody else have anything else? I think we're getting close to time here. Okay. So before next week, I'll do what you suggested there, Jeff,
Okay.
and see if I can put together a couple of profile potential proposals, that might work or that people can get feedback on, and just in terms of bus lists and stuff like that.
Okay.
And then we can discuss about which ones are worth fleshing out.
Okay. Sounds good.
All right. Anything else, guys? Okay, I think we can go ahead and enter that. Thanks, everybody.
Yeah,
Thank you. Bye bye.
Bye now.